Good morning, student. Welcome to lecture number 3. Today we will discuss about the pipeline architecture types. There are two types of pipeline architecture. One is synchronous pipeline model, another one is asynchronous pipeline model. In synchronous pipeline model, it is related to the clock pulses, whereas asynchronous pipeline model is not related to clock pulses. It is working in a principle of handshaking signals. In handshaking signal, there are two types of signals are there. One is ready signal, another one is acknowledgement signal. So these are the diagrams of this is what synchronous pipelining model and this is what asynchronous pipeline model. So let's go through details by the help of diagrams. So come to here. This is a synchronous pipeline model architectures. Here number of latches are there and number of stages are there, and each stage and latches are connected with a unique clock and each latches are synchronized with their different phases or stages. Here look here, this is what stage number 1, this is what stage number 2, and this is what kth number of stage, or you can say phase number 1, phase number 2, and this is kth phase of this pipeline. Okay, so when the clock signal is when the instruction is loaded to this pipeline, after that the clock signal is applied. When the clock signal will high, at that time the corresponding latch is ready to give his output to input to the input to next phase or stage. Again when the clock signal or clock pulse is high, again the latch is ready to give his output, or you can say input, to S2 to execute the or to continue the process. Similarly, at the when the latch or when the clock pulse is high, always he is ready to give his output to next phase as a input. So similarly, it will continue when the clock pulse is applied to this pipelining, and all latches will work correspondingly or synchronously with their phases. So look here, this is called what? Tau d. This is called what? Tau d means this is, I told you in my earlier video that tau d is what? The less delay is called what? Tau d, and this is what? Maximum phase duration. This is called what? Maximum phase duration. I told you in earlier video that always we have to prefer the maximum phase duration of a pipeline. How? Now, there is number of phases are there. Some phase may take less time, some phase take may maximum times. So we have to prefer the maximum time as a stage duration or phase duration. Look here, S1 is a phase and S2 is a phase, where S1 is taking 5 seconds and S2 is taking 10 seconds. So S1 can complete his task. If we will take 5 seconds as a phase duration, then what will the problem? Look, when S1 will complete his task within 5 minutes, but S2 cannot complete his task within 5 minutes, so problem will create, or S2 cannot be complete the task, cannot be complete his execution process. So that's why always we have to prefer the maximum phase duration of a pipelining among all stages. So tau equal to maximum phase duration plus latch delay. Maximum phase duration means this is tau I equal to 1 to k, means kth number among all kth number phase up to kth number phase. Among all phases we have to take the maximum phase duration to calculate the time period. So tau is called, also you can say tau p, or you can say tau t also you can call. This is called total phase duration or total time period to execute a instructions. So tau equal to maximum phase duration plus latch delay. So this is all about your asynchronous pipeline model. Then next come to synchronous. This is called all about your synchronous pipeline model, and this next come to asynchronous pipeline model. So what happened in asynchronous pipeline model? It is not related to the clock pulses, but there will be some handshaking signal through which both devices or both phases are communicate with each other. There is no interface, or there is no latch interface or register interface or buffer between the different phases. They directly communicate with their each others. Okay, look, here S1 phase is here and S2 phase is here, and this is my kth number of phase. So first what happened, now S1 send a signal to S2 that I am ready to send you output. How he will send the signal? By the help of ready signal, he will send a signal to S2 that I am ready to produce my output to you as your input. At that time, when S2 get the ready signal from the S1, he analyzes or synthesizes the request and return a feedback to S1, that is called acknowledgement, that yes, I am ready to accept your output. Then S1 will send the output by the help of this bus as an input to S2. Similarly, they continue their execution process. Get it? This is called what? Asynchronous pipeline model. So what do you mean by asynchronous pipeline model? The asynchronous pipeline model is a process through which different phases or different stages are communicate with each other without using latches or register interface between them. They directly communicate between the phases. And how they communicate? They communicate with each others by the help of handshaking signals. And in handshaking signal, there are two types of signal. One is called ready signal, another one is called acknowledgement signal. So ready signal send a signal to another stage that yes, I am ready to send my output. At that time, the another stage synthesize the signal, and if he is ready to receive the output, then if he is ready to receive the output of previous stage as an input, he will give a signal to the previous stage, and that is called what? Acknowledgement stage or acknowledgement signal. When the previous stage or previous phase get the acknowledgement signal, yes, the next stage or phase is ready to receive my output as an input to next stage, he will send his output by the help of this bus as an input to the next phase. So this is all about your asynchronous pipeline model. So look, so pipeline architectures are two types. One is synchronous pipeline model, another one is asynchronous pipeline model. In asynchronous pipeline model, in synchronous pipeline model, all it is related to the clock pulses, and each latches are correspondingly working with their phases to complete the instruction cycles. And here maximum time period will be maximum time period, or you can say phase duration on total time period equal to maximum phase duration plus latch delay. Here in asynchronous pipeline, it will not working the principle of clock pulse, it is working the principle of handshaking signals, and these two handshaking signals are ready, and another one is acknowledgement signals. So this is all about your pipeline architecture types.